This is the machine learning foundations for product managers project report from Curtis Conkey, December 2024. For this project, we were told to look at data that was gathered from a 2014 study on turbine efficiency, and that they had 1 hour data that they collected on 3 features and 1 target, that being the program or the turbine efficiency at producing energy. You could use one of 3 projects: Excel, Python, or Google Auto AML. I thought Google Auto AML sounded more interesting to see how a commercial product worked, and thus I used it. It's also called Vertex AI. In doing this, I ran several runs, but I ran 4 runs for record, if you will. And early on, I ran a run in which I didn't know how long to state how long to run it, and so I set it for 3 hours. And after that, I found out that after 2 hours it's basically flat, and I wasn't gaining anything. So I set all of these for 2-hour runs. From that, I then ran 4 features, 1 target, root mean squared error, and root mean squared log error. And I ran both of those, and the data I got indicated that the atmospheric temperature and vacuum were by far the most important features driving turbine output. The ambient pressure and the relative humidity were both below 10%, and I ended up with numbers along here. I'll show you a summary of these in a minute. And then from there, I wanted to see what root mean squared log error would do, so I ran that and got the same basic output, although the atmospheric temperature did run up into the above 60 here. It was still the predominant one, and but my validity numbers basically dropped a little bit, and so the quality of the run wasn't as high when you took out some of the outliers. So I take it the outliers weren't that big in this model. They were all fairly close. So then I ran 3 features, and in 3 features I dropped out the relative humidity, and as you would expect, the numbers actually stayed fairly close, but the number for atmospheric ambient pressure came up and totaled those 2 out. But the same effect was still there. Temperature and vacuum were the key drivers. But what's interesting to note, and I'll show you this in a summary chart here in a minute, this had the actual best R squared. So found that interesting. And then I ran 2 features, and obviously you've got bigger numbers for temperature and vacuum, but the overall R squared dropped, and MAE rose a little bit. So that was interesting. So from that, I took all the data and plotted it and came up with that 3 features, 1 target actually had the best output for me, best R squared and the best MAE. So that was the highest one, although it was fairly close, as you can see, to 4 features, 1 target. But 3 features, 1 target was the best run. I learned a lot about this. One thing that I found interesting was that with just 9,000 entries, in my mind that was a small number, but it still took 2 hours to run, given some of the data sets out there that you hear about that are millions of runs. So it gave me a better understanding for how compute intensive this process really is. So with that, that's my report. Appreciate the opportunity to do this, and thank you.